Hello, and welcome to part 3 of the Safety Studies course. My name is Paula Hyman from the Ohio LTAP Center. I will be your technical support for today's webinar. Please note that today's session is the third of a 4-part series, with part 4 taking place Friday at 10:30 a.m. Eastern Standard Time. Before we begin, I want to cover just a few housekeeping items. The questions throughout the presentation, as you have in previous sessions, please put those into the questions box. Our presenter will address your questions periodically throughout the presentation. Go ahead and locate that now. Just drop a hi, hello. Make sure you know where it's located and how it works. Lastly, in the handout section, there are documents available to download. If for some reason you're unable to download those, don't worry, they will be emailed at the completion of the webinar series. We'll send all of those out to the group. This webinar is being recorded, and providing that the recording is successful, following the 4th session tomorrow, the link will be emailed to all participants and uploaded to our LTAP website. Thank you in advance for your participation, and I'll pass things off to Ms. Cindy Yerke. Cindy?
Thank you very much. Just double checking, can you hear me all right?
Yes.
Perfect, thank you very much. Welcome today to the 3rd part of our Traffic Academy Safety Studies series. We are again excited to have you back. And today we will be going over the next stage of that training. As we've talked in the past, we're not going to reintroduce ourselves. Today you'll have me, Cindy Yerke, and I covered Module 1, and today is Module 3, so I'll be going through that with you. And then tomorrow you will also have Alex Maestros back as a presenter. As Paula suggested, please enter your comments into the chat box. They'll be addressed at a minimum at the end of the course presentation, but I will try to pause throughout the presentation to take a look at the questions and comments we might have. In order to receive the full credit for this course, attendees must complete all 4 webinar sessions and successfully complete the online multiple choice test within 2 weeks after the course completion. Now, each of these individual webinars are each worth 1.5 PDH credits. So at least you can know that, but in order to get the Traffic Academy Safety Studies completed, you do have to take all 4. Please, like I mentioned on Monday, take that test as soon as possible after you receive the link from LTAP. It's generally only active about 2 weeks, and then after that, the option to take the test shuts down. So in order to receive that credit with as little difficulty as possible, you'll need to take that within 2 weeks. And then typically the webinar PDH certificates are sent out within about a week of the webinar. If for some reason you don't receive your certificate within about, I would say, give at least up to 2 weeks from tomorrow's webinar, please reach out to LTAP and they should be able to help you. So as we're working our way through the agenda, you can see we've covered modules 1 and 2. Last Thursday, we went over the safety program, the ODOT safety program, and I gave you a little bit of background and an overview of the highway safety manual. Alex on Friday got into the details of how to start to develop that safety study. Today, we're going to step back into the highway safety manual. It works along the same lines as Alex was talking about the analysis process that ODOT uses for identifying that potential for safety improvement. We're going to continue that discussion, and then also in a little detail of something similar to Monday, we're going to talk about the freeway safety analysis. It's a little bit more detailed, and there's a few points in the safety analysis that we like to point out so that you're just aware of it. And the process for doing the safety studies for freeways, I guess, just requires a little bit more attention and discussion when you're doing the scoping, so we're going to talk about that as well. At the end of today's session, we're going to talk about the interpretation and documentation of safety analysis. We talked a lot about, what's in the HSM, why it's new, why we're using it. We're starting to talk about building that case for the safety study and the request for safety funding. But there is an important component that we do need to talk about it, and it is how do you interpret and communicate that safety analysis to the best of your abilities? And what are the things that you can do to protect the agency that you're working for, against any risk associated with any of the safety analysis or the conclusions in your document. And then actually at the end of today, we'll also talk a little bit about things outside of the safety study process, how to use what you're learning today, not only in safety study analysis, but in other things, and how really it shows how this process, even though it may start with a safety study, it carries its way all the way through ODOT project development. When Alex joins us tomorrow, he's going to talk about any additional studies that need to be taken care of, evaluating the countermeasures, and he'll give you a nice ECAT demo. And then finally, we'll wrap it up tomorrow by discussing how to develop the plan and finalize the report. But today, like I said, we're going to first dive into the freeway safety studies. So interchange and corridor planning and design issues that typically come up in the projects that we deal with on a regular basis in Ohio and that ODOT deals with on a regular basis are things such as configuration, changing of configuration in particular. You know, I think all of us have been familiar and have possibly seen a cloverleaf interchange that's been revised with directional ramps and have changed you know, the design. That is something that ODOT and we as transportation professionals deal with on a regular basis. You know, it gets down into things as granular as the design geometry, interchange spacing, weaving versus CD roads versus ramp rates. These are all things that go into the configuration of an interchange. Design level of service. You know, this applies not only to ramps, but also to the freeway sections. You know, the number of lanes and the amount of traffic for which the design should accommodate, and how really frankly that balances you know, capacity with safety needs. And that's, you know, these are all areas where safety can come to play in the transportation decision-making process for interchanges and freeways. Also a big one, you know, we're trying to relate these safety analysis to things throughout the project development process. Design exceptions is a big area where the safety analysis is used to support that as well. So there are some chapters on freeways and ramps. They were originated by a project, NCHRP Project 1745, originally to develop a tool that was called ISAT-E, which was an Excel-based tool, and it was an interchange safety analysis tool enhanced is what they called it. But really what it was is it was an Excel-based tool to complete freeway safety analysis based on a combination of research that had been done for freeways and interchanges. The research, this was some of that research. If you remember on last Thursday, we talked about, you know, the HSM was a combination of past research and research specifically commissioned to develop the highway safety manual. Well, for this case, the freeways analysis did fall into that latter category, and the research for the freeways and interchanges was completed in later 2011 and then finally ready for publication in September of 2012. That's why it was not included with the original HSM. They wanted to roll out the HSM as soon as they could, so they went ahead and did that with the chapters and the site types, you know, the rural 2-lane, rural multi-lane, urban and suburban arterials. They did that as soon as they could, 2010. And then they followed shortly thereafter with the freeways and interchanges. So it was approved for publication in 2012. Now, by approved for you know, publication, that meant the research project itself. It wasn't until 2014 that it was actually rolled out into a published volume of the Highway Safety Manual, and that became what's called the First Edition Supplement 2014. And that includes chapters on both freeway segments and then also ramps. And when I say ramps, that includes the ramp segments themselves and then the ramp terminal intersections with the cross streets. So what are some of the Highway Safety Manual freeway applications? This is going to sound very familiar because we talked about it, and it's really very familiar and very similar to the other site types that we've talked about. We're able to predict crashes before and after we reconstruct a corridor. You know, it should sound familiar. We talked about predicting crashes before and after we construct another type, all of the other types of roadways. It's going to allow us to evaluate the effects of adding new features, such as a new interchange. We can predict, you know, differences in expected safety performance between different interchange configuration alternatives. And then we can also evaluate and refine geometry as we're working our way through the design process. The crash prediction for freeway segments and interchanges is essentially the same structure as what we talked about on Monday. It's a statistical modeling process. It's very similar to the other chapters. There's safety performance functions, crash modification factors, calibration factors, and similar to the chapters 10, 11, and 12, data from California, Maine, and Washington State were also used in developing those models. What is kind of an important thing to point out and is of interest is that when developing the freeway models, it required a lot of data collection, and it just wasn't feasible to do that data collection on the ground. So in this case, Google Earth was used to obtain the horizontal and cross-sectional data on hundreds of miles of freeways and interchanges. And why do I tell you that? Because that's giving you that hint that the majority of what we can do can be from a desktop perspective. It does not require a ton of extra effort. It shouldn't be more than what you have historically done in the past when you've been looking at interchanges from a safety perspective, and it really can be accomplished quite easily with a majority of data using tools such as Google Earth or the road viewer options. Of course, it's always better to have plans, as-built plans, or have real data measured from the field. But the reality is when we're dealing with some of these larger improvement projects that we just really, particularly at the planning stage, don't have the time and often the budget within the safety studies to go out and collect that data in the field. Why do we care about this? Well, like I said, there are 3 components of the chapters 18 and 19 that refer to freeways and interchanges. And as we talked about, freeway segments, ramp segments, and then the ramp terminal intersections with crossroads are covered in those 2 chapters. So what I wanted to do with the next couple slides is really just talk through and show you what kind of data is needed. If you recall back when we were dealing with, I think on day 2, Alex showed that, you know, additional data that you needed to collect for roadways as compared to what you previously did with safety. The type of data is very, very similar. You're going to collect your basic roadway data, you know, length, number of lanes, area type. You'll document where there's curves. You'll document cross-sectional information. You'll also collect roadside data, and then you'll collect details on the ramp access. So this is all information that you need to know when you're doing freeway segments. You might think that freeway segments should be very simple. They're very typically very consistent. In fact, freeways tend to be more consistent in terms of design than the other types of roadways that we talked about last week, but there is still the same type of information that is needed. And this is because there has been a lot of that research documented the effects of changes in each of these data points and what those effects would have on safety. We also have to have information on AADT for freeway segments, for entrance ramps and exit ramps, and sometimes the crossroads if we're doing the crossroad analysis as well. And then in the case of freeways, there is a component or an attribute that we collect to allow us to calculate a ratio that is an approximation of congestion, and that is the proportion of AADT during high volume hours. So freeways is just slightly sensitive to the congestion issue when it comes to predicting the crash frequency and safety performance. Just one moment. There we go. For ramp terminal intersections, very, very similar data to other intersections. We have to have that basic intersection information, the area type, the terminal configuration. If there's non-ramp public streets accessing or possibly opposite a ramp, we need to know that kind of information. The skew, distance to nearest intersection on the crossroad, traffic control, presence of protected and left-right turn control on the crossroad, and then the cross-section information. Also, we look at access data, number of drives, ramp access, the presence side, length of speed change areas for your ramps. As you can see, why we're talking about freeways separately is because it is and does require more detail. I think it requires additional data due to the complexity of the design context. And so we want to make sure that we go over all of that with you and you have a good understanding. The freeways analysis is probably freeways and ramp terminal intersections, the more labor intensive of the analysis that you might do. because it does require more of that design detail to capture the effects on safety. So in Freeway Analysis in ISAT-E, if you were to go and use that tool, and if some of you are from out of Ohio, you might have experience using ISAT-E. You know, it's something that you can access through AASHTO's website, and that tool analyzes the directions of analyzes both directions of the freeway at the same time. So when you're entering information, even if you're doing something that might change only one side of the freeway, the model and the model approach actually asks for you to submit information on both sides of the freeway, and you get then the whole cross-sectional appreciation of the effects on crashes. There are some situations with significantly different cross sections or differing number of lanes by direction that require some special analysis approach, and we'll touch on that briefly. But the good news is ECAT, which is what we do in Ohio, actually allows for analysis by direction. They have set it up so that you can indicate that you need to do only the directional analysis. Let's say you're just making an improvement at a ramp or a pair of ramps on one side of the freeway, then you're able to do that analysis in ECAT by direction. One of the things that we like to point out that's particularly important, frankly, it's important in any of the analysis that we do, but it's particularly important in the freeway that we get consistent segmentation. You're going to need to divide your facility, your ramps, the segments into homogeneous segments, and then also separate out the intersections. It's most important, and doing this segmentation is the most time intensive part of the analysis. But frankly, the more homogeneous, or in this case, the more consistent that all of the variables are within the particular segment that you're analyzing, the more accurate the results are going to be. So there are some limitations. Presently, there are some site types that are not addressed. Facilities with HOV lanes, freeways with managed lanes separated by a buffer zone or a buffer area, ramp metering is not covered, frontage roads are not covered, and speed change lanes at crossroads. And what do I mean by that? I mean the merge and diverge areas on the crossroads when you have a ramp introduced to the crossroad and merging with the crossroad. If you have a formal acceleration lane from that ramp before you merge into the crossroad traffic, that is not specifically evaluated like it is on the freeway segments. Geometric elements that are not addressed, vertical geometry are not taken into consideration. Greater than 10-lane freeway segments presently are not possible to be analyzed, and then greater than two-lane ramp segments. Differing barrier types, the process does not differentiate on the impact, of different types of barrier, cable versus jersey barrier versus guardrail. A crash is a crash in the mind of, or in this particular context, even if they might produce slightly different results in terms of perhaps severity. But some of the stuff is changing. They're increasing, they're doing some research to increase the number of lanes on ramps and a number of lanes on the freeways, and you should be expecting to see that at some point in time in the future. So regarding those special conditions that we talked about, the freeways with barrier separated managed lanes, they can be analyzed if you're analyzing what would be called the general purpose portion of that facility. So the normal lanes, the lanes that are not restricted to a particular type of traffic. However, in that case, the managed lane, so whatever is inside, the area, which is usually typically in the median, that is assigned to the express lanes or the hot lanes, the high occupancy transit or high occupancy vehicle lanes are not considered in that analysis, and in fact, they're just treated as part of the median. And like I mentioned, the analysis then is performed for the general purpose lanes with the managed lane entry and exit points treated as entrance or exit ramps. So really, when we say we can do it, we can do those managed lane facilities, we can do partial analysis. Toll facilities, they can be analyzed, provided that the section is and represents something very similar to a normal highway section. So to do that, it needs to be sufficiently distanced from a toll facility so that the facility itself, that toll, the tolling booth, doesn't influence the vehicle operations. And then the areas in the immediate vicinity of the toll plaza, if they're widened to accommodate vehicles, or areas that experience queuing or speed change lanes for those areas to exit and enter from the tolling booths themselves, those are not part of the area that is analyzed using the HSM. Calibration, similar to what we talked about last week. The models in the chapters 18 and 19 are derived from multiple state databases. The key to note here is, the reporting thresholds vary state by state. So we'll talk about that, when I talk about use of an uncalibrated model. In many times, some of the first uses of the new highway safety manual analyses was for freeways. And at the point when, back in 2012, 13, 14, 15, and still now, many states don't have HSM calibration factors. The good news is for freeways, you can do still a pretty good job of evaluating a roadway system. Obviously it's preferred to be calibrated, and ODOT has the calibration factors, so you don't really have to worry about it if you're working in Ohio. But if you're outside of Ohio, uncalibrated model for freeways is still a particularly good analysis tool. One of the reasons is, freeway design from state to state to state is a little more consistent because, rural, 2 lanes, multi-lanes, and even urban and suburban arterials can be very context sensitive. But the consistency exists more in the freeway type facilities as you transition, across the country and through different states. So it still is a very effective tool. If you remember just a few minutes ago, I said something about the reporting thresholds vary by state, vary state by state. What that means is really about PDOs, property damage only crashes. There's different thresholds. In some states, it might be, a value of $1,800 or $800 damage or more. Some it might be $1,000, some it might be $1,500. So that differentiation between what is and isn't a property damage only crash is a little loose. So while the freeway models might not be the best fit for predicting those property damage only, because of the consistency across design across the country, those higher level crashes, though, in terms of severity, the fatals and severe injury crashes are a little bit more consistent within the models. You can, if you're going to evaluate different alternatives, you can compare predicted crash patterns against observed crash patterns, and that is still a very meaningful metric. You can't necessarily say that you can predict what you would actually expect to happen for a facility, but you could say that you can predict the impact or what might happen if you implement a certain change or treatment. You could see things in terms of, are the crashes going to go up or down? What is the order of magnitude of the change? Or should I expect a change in potentially the severity that we might get due to a particular geometric change or improvement? So for the predictive methods for freeways, this is what you have to deal with when you're dealing with your safety performance functions. There's quite a few of them. There are safety performance functions in terms of rural versus urban, number of lanes, single vehicle, multi-vehicle, fatal and injury, property damage only. The good news is generally speaking, it's the same general form of the equation, but it's different variables and such that go into the information to calculate the values that come out of those. So this is what one of those safety performance functions might look like. If you remember on Tuesday, we had a nice smooth single line for what might be a rural 2-lane. In this case, if we're looking at a freeway segment, we might have multiple lines, so multiple equations, or I guess multiple curves, depending upon the number of lanes you have and whether it's rural or urban. And so if you were to plot these on a graph, you might see something like this. For freeway segments, there are a whole selection of crash modification factors, and on the screen, you can see the list. But similar to what we talked about on Monday, all of the crash modification factors in chapters 18 and 19 were developed specifically to work with the safety performance function. So they were determined to be those independent variables that when you changed values, they would affect safety, and they were derived from the same research that those safety performance functions were derived from. Most of them, in the case of freeway segments, are functions of geometric variables. And in the case of freeways, we actually look at things in terms of single vehicle versus multi-vehicle type collisions. A couple of the attributes that we really want to point out that are important to understand, we're going to go over those now. Median barrier is one of those. It can seem quite intimidating when you're actually trying to evaluate a segment that might have multiple bits and pieces of median barrier because they can be installed continuously or they can be installed in pieces to protect individual objects or areas of concern on the side of the road or in the median. And so the key things are, when you're calculating and estimating the impact of a median barrier, or in this case, median barrier, you're going to need to know the length and the offset to the median and the roadside barrier. And then also, if you're dealing with a continuous barrier, you're going to want to know the width of the continuous median barrier. What do we mean by that? What we mean is when you have continuous barrier on the median, in the median, you would look at it a couple of different ways. If it's only on one side of the road, then there's a very specific value used for the width, depending upon the type of barrier. If you happen to have continuous barrier on both sides of the freeway, then you actually would count the width being as the face-to-face, you know, from barrier to barrier, basically treating that area within the median between the barriers as one solid median that cannot be crossed. So that width of the median barrier then really becomes the width and the distance between the two continuous pieces of barrier on each side. Why are we telling you this? This means that when you're actually, if you really want to get a good picture of what your freeway, you know, what your proposed freeway improvement or perhaps reconstruction might do in terms of safety, you really do need to consider preliminary barrier layout at an earlier point in the project development. This doesn't mean you need to go overboard. It just means that you need to be aware that placement of barrier is one of the things that has a significant influence on crashes on a freeway, in a freeway environment. And you simply can't lay out a roadway improvement, perhaps, you know, a lane widening or a lane addition, and forget or fail to recognize. And one thing, like, for example, a lane addition, if you were going to take perhaps, you know, a 4-lane freeway and convert it to a 6, you can't simply just change the number of lanes and say you're done, because we know that when you add that additional lane, chances are whatever was on the side of the roadway is now even closer, you know, to what the travel way. And if you're protecting more, if there are more objects that need to be protected because you can't establish that clear zone, then that's going to mean more barrier. So you have to consider that barrier when you're doing the design. And most of us know that this happens fairly early in the process when you're considering those kinds of layouts. Another attribute that you need to be aware of is high volume. That if you remember the volume variation during an average day, we develop actually a proportion of ADT that occurs during the hours where the volume exceeds 1,000 vehicles per hour per lane. What this is intended to do is capture situations when there's hourly volumes that are continuously high, or perhaps some situations where there are a few high peak hours, and supposed to help us capture what the effect of having that congestion might be on safety performance. What you do is you basically sum up the ADT, or you sum up the volume during those hours that exceed 1,000 vehicles per hour per lane. You sum up the total volume, and then you divide that by the total ADT for that section. Then, you know, what you can do to capture this data, obviously the best thing to have would be an actual traffic count. But when you're doing things for safety studies, we don't often have that information. So in that case, you would typically use your nearest traffic count station, ATR, data to help you estimate that. If you do not have one nearby, then what you would want to do is talk to ODOT. So another key thing that you really need to understand also that in fact influences safety. Most of this is probably common sense in that, you know, it makes sense that these would influence crashes, But what's especially critical is to capture the spacing and the actual distance between ramp entrances and exits. So ramp spacing does impact what's called a lane change CMF. What that lane change CMF does is it captures that turbulence in the segment immediately upstream or downstream of an entrance, upstream of an exit. So it's going to capture the impacts of that turbulence that happens as vehicles try to switch lanes to get into a position where they can either exit, or once they enter, to get into a position where they're merged into the normal traffic flow. It is a really useful metric during design phase, during the design phase. It helps us understand, how the impact of the spacing of ramps would impact the safety or the anticipated safety on that particular segment. It also lets us look at things such as, what happens if we remove a ramp entirely. The HSM also wants us to tell them when, in this case, ECAT and the tools also need to know, or we need to enter information and collect information on the type B weaving. Most of us are familiar with this from a while ago. I think it was in AASHTO, but if you're familiar with a type B weave, you can see it up on the screen. And really what this is they discovered when they were doing the modeling and developing the models that the models didn't quite capture this one particular condition. So what you do is by entering the appropriate information, it's able to recognize if it is a type B weave, and then that would trigger this supplemental kind of CMF that is associated with it to add in the appropriate crash prediction associated with that specific weave type. So, next one. Ramp spacing and taper lengths are incredibly important. You need to, when you're entering data or entering information on a freeway segment into ECAT, you need to know quite a bit of detail on your ramps. You need to is a lane add entirely or a speed change lane. Lane adds are in the HSM. There are some specific lengths of that area. Basically, it's whether or not you treat that lane addition, that full width lane addition that's part of what would be kind of the acceleration area, whether or not you treat it as a full lane as part of the freeway, or you treat it as part of the ramp acceleration area. And it's really dependent upon the length of that area. You need to understand, you need to define the length of the entrance and exit ramp between taper point and that 2-foot gore separation, and you need to establish which side it's on. And so that's if a ramp is in the segment. If a ramp is outside of the segment, what we're concerned about is there an upstream entrance or a downstream exit? Again, back to that comment earlier about trying to capture the effects of the turbulence that happens within those areas that are upstream of your segment, and then also downstream, and then what impact that has on the segment itself. So you will, when you're looking at this, I'm not going to go into detail, but this is probably the most challenging part of the analysis, is just getting your head around where you're going to measure the froms and the tos. And so I encourage you definitely, when you get to this point of your analysis, look at the instructions in ECAT, talk to your safety coordinator if you're confused or you have any issues, because this is probably the most challenging aspect of doing freeway segment analysis. For ramps or CD roads, like I mentioned before, we can't do frontage roads, but we can do CD roads because CD roads are treated like ramps. So when we actually do ramps or CD roads, we treat them like they're mini road segments. And so we're going to do the same thing that we would do to any segment. We divide it into homogeneous segments. And then the things that we're concerned about if there is another ramp merging into the segment that we're looking at. Is there another ramp or a ramp lane exiting from that particular segment? And then also we can do the different types of segments. We can do an entrance ramp segment, an exit ramp segment, and then crossroad ramp terminal intersections. For freeway ramp segments, Like I mentioned, it's segment based. It works for all ramp configurations up to 2 lanes, presently up to 2 lanes, similar to freeway segment analysis, and also is used to analyze CD roads. If you have one consistent cross section throughout your entire length of your segment, you could treat it all as one segment. But typically speaking, you're going to probably see some changes, possibly in shoulder width or other things, maybe lane width within the limits of your actual ramp. So then you would need to do the same thing you would on any other roadway segment. When one of the items, and the easiest way to say for ramp segments, if one of those attributes changes, probably a good idea to cut a new segment and segment your ramp. This looks very similar to the freeway. The freeway safety performance function for ramps, it's defined by whether the ramp is a segment is an exit ramp, an entrance ramp, or a CD road. You'll consider area type, meaning urban versus rural, and the number of lanes. Something that I don't know that I pointed out yesterday, and I don't know that Alex pointed out necessarily, and even if we did, I'm gonna repeat it. When we're talking about area type, you need to be very cognizant of what we're dealing with. We are not looking for you to define area type by functional classification per se. You may be able to establish that generally. However, if, for example, in freeway situations, it's probably fairly fair to do it using functional types. You should be considering the design as in terms of helping you determine whether it is a rural or an urban design. If your existing location is a rural design, even if it's on a road that is functionally classified as urban, you're still going to analyze it using the rural tools. So I just wanted to point that out. I don't know, I don't remember that we specifically stated that, but really any of these things, any of these models that we're using, we should be doing them based on what the design tells us that it was designed for, the area type. So that is what we should be doing when we're looking at evaluating something from the existing conditions. Sorry, here we go. For freeway ramp segments, you can see the crash modification factors up on the screen. They're similar to the other segment-based analyses that we have seen, particularly for freeways. You'll be documenting whether or not there's a curve. You'll document things like the lane width, the shoulder width, whether it's the right or left shoulder. You'll determine, if there's barrier on the right or left side or both. Do you have a lane add or a drop? Do you have another lane entering or exiting? The ramp itself within the limits of the segment you're evaluating, or upstream or downstream. And then is there a speed change lane within the ramp from another ramp connecting to it? And that really, probably happens more with the CD road type situation, but it can happen for individual ramps as well. And then for specific to CD roads, you also evaluate the weaving section. So what are some of the key important attributes that you need to be aware of for ramp segments that sometimes can be a little confusing? For ramp segments, the big one really is mileposting. Mileposting is important because it's used to model the speed of the vehicle along a ramp, because what we want to know is we want to know the speed of that vehicle entering the curve, because that is what influences, by the time it gets to the curve, that is what influences the safety performance of a particular ramp segment with a curve. So the milepost, what that's going to indicate, it's the distance along the ramp to the start of the curve. And what you would do is establish one milepost 0 for all segments on the ramp, and then reference that distance to the curve from that milepost 0. So when you have a situation where you have common entrance or exit locations, you're going to establish one milepost. So, and you can see up on the screen, we have that situation. We have one ramp splitting to 2. So your reference point when you're doing your distances to the curves is always going to be from that same milepost for both of your ramps. Where this is a little different is where you have 2 ramps coming together. When you have two ramps coming together, you're going to actually have to consider a milepost 0 for both of the independent parts of the ramp. And then once they are combined, you reference the combined section to the ramp milepost 0 that has the highest volume. So in this case, if you were looking here and ramp 1 has the highest volume, then those segments that are combined that you see after the dashed line and the solid line come together, there's two segments. The distance to those segments and the start of the segments, because that first one definitely has a curve in it, and you're trying to capture, if a vehicle is entering and they are coming along the ramps and they're about to get into that curve, what's their speed? You're going to reference that from the milepost 0 of the one with the highest volume, because the one with the highest volume typically sets the pace. Ramp terminal intersections. What do you need to know about those? This is the most rigid and difficult part of the of the ECAT and the HSM analysis. There are only 7 configurations. Why do I say only 7 configurations? I mean, these are the basic, configurations for standard interchange ramp terminal intersection design. But if you were to go out into the field and you were trying to find and determine if every ramp terminal intersection could be fit into this category of 7, you're going to find that it is almost like flipping a coin as to whether or not it will or won't. So this is a challenging part of the analysis. This is why when you're doing freeway analyses of any type, you are coordinating closely with your district safety rep to make sure that you are doing it as best you can. The answer in most cases is not to not do it. The answer is usually to try to find one of the options or one of the analysis options, the 7 that fit the closest, and then find a way to do some analysis based on that. But that's one of the reasons why for freeways, you definitely want to be coordinating early with the SRT and your district safety reps to make sure that you're following and capturing the analysis correctly. So for ramp terminal analysis, the safety performance function is traffic control, cross-section, area type, and volume. And then the crash modification factors look at things like the other intersections that we've talked about, but with a little bit more detail. It considers things like the ramp capacity, whether or not there's turn lanes on the crossroad, if there's access points in the vicinity of the crossroad ramp terminal intersection, segment length, the median width, skew angle, signals. There's a lot of information that you need to know, and actually the intersections themselves, these tend to be, of all of the site types in the HSM, both volume 2 and then this supplement, this tends to be the most complex. So if you're going to refer to ECAT and you're going to look at what we might deal with when we're doing freeway analysis, this is what you might be presented. And this is the input for the freeway segments tab. And as you can see, there's a couple pop-ups. There's the curve data and the median barrier data information. As we were talking about some of the things that are more sensitive, the median barrier stands out, and that's going to be one of your more complex methods, or one of the more complex things that you have to analyze. And this is the second part of the freeway segments tab. And then here's what the ramp segments look like and the ramp terminal intersections look like as well. A lot of data, to be honest with you, and that's why we are spending some time just to go over freeways, because a couple of the attributes are particularly challenging, like I mentioned before, and we want to make sure that you have some familiarity and those attributes that probably might create issues or for you when you're doing the analysis, and that you should be definitely considering it. Perfectly acceptable. All questions are acceptable, but you will potentially encounter a few more bumps when you're trying to learn how to do these types of analyses. So when you're reviewing the results in ECAT, you're going to get a report that looks something like you see on the screen. It will include, several different areas. There will be at the top the general information about the project, and then there will be a bar chart that shows the summary of safety performance. And in this case, to be honest with you, this output in this format is very similar to anything that you would get out of any of the chapters, but we're going to go over this in particular here so that you can just get a feel for what you might see and how you might interpret it. The safety performance summary in the bar chart, that actually just tells you your existing, expected versus your predicted, and gives you the potential for safety improvement that we talked about on last Friday. And then you'll also be able to see things in terms of predicted crashes, crash summary by element. In this case, there was only one element that was evaluated. It was a ramp terminal intersection, I believe. But if you were to have a corridor, or you would have a freeway section that included both an interchange or interchanges and freeway segments, you can have numerous elements that are listed here in a list. You will have summaries by crash types, and you will also be able to find element details such as all of the CABCO detail and crash type, etc., could be found on the individual element tab. So once you divide, and when I say individual elements, I mean your segment or your intersections. You're going to start off the process by segmenting and separating out your segments and intersections. You're going to get your output in terms of those same that same division. And while the summary page and the report itself shows the summary of everything, you can go back to the individual segments or intersections or ramp segments if you want to get details on the specific areas. Why is that important? Because sometimes when you're evaluating, a larger section of a freeway that maybe includes, an interchange in freeway sections, or maybe it includes a couple interchanges. There could be a variety of ways that you might use this tool. You want to see where the issues are. You don't want to just be looking at it from the high level overall. You want to see, is there a particular ramp that actually stands out and that's an issue? You can identify that by the element list. You can see where there are, where there's a potential safety improvement by the individual element. Then you can go back to that specific area. You can say, okay, I have, 5 freeway segments and 4 ramps that I have in my list, and ramp, ramp H, or whatever the ramp, is really where we're seeing the highest potential for safety improvement. And you can drill down in on that ramp and determine some appropriate safety investments for attempting to improve that safety. So this is just a larger blow up of what you saw before. At the top, you're going to see your totals, you're going to see your overall, but then you're going to see your predicted, expected, and potential for safety improvement by element. In this case, it was just one intersection, but if you have multiple intersections, if you have multiple ramps and freeway segments, then you're going to see all of those listed, and you'll be able to figure out where are the areas that are of highest priority. And then I will say, it looks to me like the slides are out of order, they're backwards. So reviewing your results, this is the top and then the summary. And then finally, you will also see a summary by site type when it comes to the different crash types themselves. So for freeway safety studies, this is where we talk about what you do. When you're trying to do your freeway, what does this all mean to you? It's a lot of information. You can see there's a lot of kind of specialty details that you need to be aware of. You can see that, if you're dealing with a pretty big study area, it can be pretty cumbersome and pretty lengthy, the analysis that you do. Well, when you get to the point of scoping at the beginning, this is where you're going to discuss that in a little bit more detail. You will need to discuss every freeway safety study with your district safety rep before you really get started, to make sure you're capturing the limits that they want to see. You may only be dealing with one ramp, but ODOT would then come back and tell you, yes, but you need to see that there's this upstream entrance at this particular exit ramp that we're of concern, so you're going to need to capture that study area that goes all the way upstream to capture that upstream entrance. So you just really need to have a conversation with ODOT so that, 1, you capture everything that they need, and 2, you don't do too much, because it could be it could snowball very quickly if you start doing analysis of a whole interchange. 10 plus years ago, when we did interchange analysis, sometimes it was that whole interchange. where we would do the safety study review. In this case, we do want to be very specific, use our money and our time wisely, and focus on the areas that we need to focus on and nothing more. When you're looking at freeway safety studies, you will do a predicted to predicted comparison of alternatives. That will be what happens. It is not possible to do the expected to expected for alternatives, particularly when there's some major changes. And so ODOT would prefer you do the predicted to predicted, but again, definitely consult with ODOT on what the analysis parameters need to be. And then you will just simply provide a summary report of the results of your safety study. I have somehow lost my chat box, so I'm not able to see if there's any questions. Okay, I guess I'm going to move forward. I do want to take one quick moment and make sure everybody can still hear me. Is that correct?
I'm sorry, we can hear you just fine, but there are no questions in the question spot.
Good. All right, because I have somehow lost that pop-up wherever it's disappeared, and that's fine. So just let me know. I will stop again towards the end, and we can address any questions at the end as well. So now we're going to move into the so what. Now that I have all this analysis and I'm getting ready to really write my report and write my study, how do I do it? How do I talk about what I have in front of me? What are the best ways to communicate things? And these slides, these next slides, are kind of geared towards things from a holistic or a bigger picture perspective. You know, you're developing these studies for multiple audiences, technically. You know, first and foremost, you're developing it for ODOT. They're going to review this. They're going to look at it and determine if you're including it with a safety funding application. They're going to determine, can you get safety funding? You know, can they give you some safety funding based on the analysis that you performed? But there's some other reasons why you do safety studies. Sometimes you do safety studies because you're going to evaluate and determine what your improvements are, and maybe you're not asking for funding. Maybe you're just doing it to help support design decisions and get ahead of what you need to do in terms of your design. Sometimes you won't even do a safety study. You'll just do safety analysis to evaluate alternatives. So all of these are various types of studies that you might do. It might not be the specific safety study itself, you know, to obtain a funding, you know, to obtain funding for assistance with the improvements. But there's a lot of types of studies that you do involving safety. So what are some of the things that you should consider when you're interpreting and documenting the results of your safety analysis? So the learning objectives of this module are just to gain some perspective on the issues of safety and risk and trade-offs. Kind of tune you in on, you know, how to deal with addressing stakeholder understanding of the two dimensions of safety. Back to, there are a lot of reasons you're doing this. There may be the need when you are moving from that preliminary planning phase to actually determining a preferred alternative and then getting started with PE, that you have to have a stakeholder or a public in your study, because whatever you communicate to that audience has to be based and should be grounded in what you've done in that safety study. We will talk about communicating safety in the report writing and stakeholder discussions. We will talk a little bit about legal protections and just kind of what you need to keep in mind. And then we'll talk about risk management, tort liability, and professional responsibility. So we're going to put this into some context. Why is this so important that you not only do the analysis, but you interpret it and you frame it the correct way? This is what we're going to talk about right now. So back to what we talked about at the very beginning, there are two dimensions of safety. There's that nominal safety, which is examining in reference and in compliance with standards, warrants, guidelines, and design procedures. And then there is the substantive safety, which is really what the HSM is all about, which is what we actually expect to happen in terms of crash frequency and severity, you know, for a highway or roadway based on the actual conditions that are there, based on the context. Why is that important? Well, most people think of things traditionally in terms of nominal safety. That's what we were all used to doing. And frankly, how many times have you seen something referenced as whether or not it meets standards or not? And that is the reference that someone as a stakeholder and the general public would use as their reference. So with the ability to communicate more detail from the HSM, there is a greater responsibility that we understand how to communicate that correctly. So just a refresher, nominal safety, what is it? It's examined in reference to compliance with standards, warrants, guidelines, and sanction designs procedures. There were 3 key aspects of nominal safety that are used when establishing a design criteria or standard. Roadway design must enable road users to behave legally, first and foremost. So that is a primary concern, and behave legally. So it's that in many cases, it establishes, if you have a certain speed limit or a certain design, you have to be able to, drive on that road or use that road in a legal fashion. It can't force you to go too fast or too slow, etc. The roadway design should enable the vast majority of users to operate without difficulty. So the design should allow you, if you follow the rules, to operate in the roadway environment if you're a typical road user without any sort of difficulty. And then the owning agencies that use these standards and use these nominal safety guidelines, they require protection against claims of liability. So how do they do that? Oftentimes they measure things against whether or not they have met standards. So that will come to play later in our conversation. It's important to note that the AASHTO Green Book and the L&D manual are not safety manuals. They are comprehensive. They deal with traffic operations, cost, maintainability, constructability, and safety. And nominal and substantive safety are not the same thing. So again, safety, but they consider multiple things, with safety only being part of the equation. Again, nominal and substantive safety are not the same thing. We deal with nominal safety in terms of standards, models, criteria, and those types of things. Substantive safety and the HSM varies by context, is directly related to traffic volume, and varies incrementally with incremental changes in conditions. So as we talked earlier, those 2 dimensions of safety do produce the 2 different outlooks. Why do we care? Because now we have to start talking about how we deal with balancing safety with other factors. So when we're dealing with explaining our decisions to stakeholders and to the folks that we're writing these studies for, we have to be thinking that along the lines that our results and our analysis will have to be used as part of this conversation. We know that we cannot build every road, that we can't build, quote unquote, the safest roads all of the time. It's just simply not financially possible. We may have alternatives that we're evaluating, and the one that would provide the best performance in terms of safety may have too many other impacts to make it a feasible alternative. Well, we need to be able to explain why we are doing that, because frankly, when we tell somebody that we cannot do that alternative because of whatever reason, they need to have some understanding of why, because in many people's minds, safety is the #1 priority. And frankly, if we don't do it and we don't provide the alternative that is the quote unquote safest, it really feels very risky. When we started this process, at the time that safety always comes first. And I have to pause and say, but no, it really doesn't, because we have to do these compromises, but we hear it all the time. Safety comes first. We can't trade off or compromise safety or we could get sued. That's wrong. That's incorrect. We are engineers and planners and transportation professionals, and our responsibility is to weigh all of the considerations when making the best decision, for the people that we are making these decisions for. Many times we heard, well, we get sued if we use a highway safety manual and we know more about safety, but we choose the wrong approach. The highway safety manual does not, it's an independent reference. It considers safety alone. It does not consider those other factors. And so again, it should be used as part of the conversation, part of the information and the data that we're using to evaluate from a holistic perspective any alternative or change that we might propose. Like I mentioned before, we don't all the safest road. We routinely trade off safety in many decisions that we make. And maybe we aren't aware of that, but maybe these are good things to point out. You know, shoulders and guardrail versus right away for clear zone. This is a big one. You know, there's many, the best condition on the side of a road is to provide the appropriate clear zone, because then when a vehicle leaves a roadway, it has either the ability to recover and return to the roadway, or if it does, the impact in terms of severity is hopefully as minor as possible. But there's nothing on the side of the road in order for them to strike. But the reality is we can't always do that. So we put guardrail in place, knowing that it's there to be hit, because either one, there is another asset that we need to protect, or two, you know, the impact to that guardrail and the redirection that a guardrail can provide is still a better chance at it being less severe than the impact to the asset itself. Rumble strips and bicycle mobility. You know, continuous rumble strips along the side of the road make sense from a vehicle perspective, but they don't from a bicycle perspective. Turn lanes and signals. You know, when you install a left turn lane or you install a protected left, there's a compromise, right? You know, you're installing a protected left to somehow reduce angle crashes, but at the same time, you recognize that you're going to be increasing rear end crashes. Alignment shifts to avoid environmental resources. This is routinely an issue, or not an issue, routinely an occurrence. Again, we are weighing multiple competing interests, and we have to evaluate and determine which are the priorities, and sometimes safety is not the top priority. Again, another one, access management, raised medians that prohibit all cross median or cross center line turns versus allowing full or partial turns into commercial access. We at times have to allow access because of a potential impact or economic impact it might have on a business, despite the fact that it's likely not the safest option. Tell us what to do, and that's a really important thing. It's not going to tell us that based on the results of your safety analysis, you have to do something specific. You are not, if you're doing that, you're not considering the other things that are part of the discussion, which include things like costs, right-of-way, environmental features, stakeholder values, traffic operations. These are all of the things and safety that you should consider when making a design decision or choice. Now back to the discussion, you know, what if we use the highway safety manual and we determine that we're going to select an alternative that doesn't show the best safety performance? And so then many people propose, well, maybe it's better off not to use this at all. Well, that is not a good response, because if you haven't been conducting safety, how do you know how safe your solution is? You really don't. And so there are also other ways that you can use the highway safety manual when you have a situation that is perhaps not you know, the highest in terms of safety performance. There are other things that you can incorporate into your design that could help mitigate for that, and that is another good way to use the highway safety manual. But frankly, you know, we need to know how that safety performance is going to perform for alternatives, so that we really can determine you know, the right path forward. When it comes to safety trade-offs, our professional responsibilities remain. You know, we're held to a standard of care that includes use of our profession's manuals and guides to our best engineering judgment. We now have the highway safety manual in that mix. That's one of those guidance documents that we now, because it is there, we should be and are obligated to be using. Another key important part of this is, as we go through this process and we're making the decisions that we're making regarding trade-offs, we have to document our work so it can be defended if necessary. So let's talk a little bit about stakeholder communications. How do we translate this into something meaningful? So one of the things that we need to do when we're talking to stakeholders, because many stakeholders still think of things in terms of standards. When you say that doesn't meet standards, it has a connotation or it connotes something negative, which that's something that we have to work to discourage, because that's not correct. Something not meeting a standard does not mean that it's unsafe. It doesn't mean that we're even going to have a safety problem associated with that design deviation. So it's going to be very important that we learn to understand how to communicate these kinds of things, and that, you know, standards aren't always representative of safety, and they're there for a different purpose. So being able, how do we do this a little bit more effectively, is use tools like the Highway Safety Manual. The Highway Safety Manual can help you understand and then ultimately help you communicate the relationship between a design element and crashes. You can be prepared to go into a discussion and say, you know, if we are going to reduce these lanes from a 12-foot to an 11-foot lane, but in order to gain, you know, 4 additional feet in shoulder width, you know, across a, you know, each side across an 8-lane section, you're able to now walk in and say, here's going to be our expected safety impact. And we're going to expect to see the crashes may increase because of the reduction in the lane width by this much, but that's going to be offset and actually overcome by the fact that we're going to gain a greater and a more appreciable benefit by the addition of the width to the shoulders. Being able to understand those individual elements can make your conversations much easier and much smoother. But when you are having those discussions, you need to make sure that you're focusing on the trade-offs. If it is a situation where you have to communicate something that is, you're selecting something that perhaps isn't the highest in terms of safety performance, or has creates a particular safety concern for a particular stakeholder, you need to always make sure that you have an ability to focus on the trade-offs where you are making a trade-off for a good reason. You know, have a range of alternatives with varying performance. Be able to talk about that, and then also talk about the fact that, you know, yes, we would greatly, you know, we would definitely love to pick this alternative, but here is the reason why we are not, and we've determined that this other impact and the negative impact of this other element outweighs the fact that, you know, it will, you know, create potentially, compared to other alternatives, it may have a slightly higher impact on safety in a negative way. When you're dealing with stakeholders, make sure you communicate the reasons or the basis for the nominal safety value, if you can identify that, so that they understand it's not indicative of safety. In fact, it's intended to, you know, for example, vertical curves is really more about driver comfort than safety at all. So, you know, I think being able to get folks to understand that, particularly when you're dealing with stakeholders, and I think the thing too is you need to tailor your communications to the audience. Stakeholders may be, when you're dealing with agencies, might be a little more savvy than the general public about some of these design aspects. So making sure that you're able to tailor your conversation to the appropriate level of detail is also important. And then making sure you're keeping that conversation and discussion as objective as possible, and use performance-based terms. Don't talk in terms of words like safe versus unsafe. We don't want to do that. Now, I've done that here in this presentation, but you can't see my hands go up and do the quotes. I try not to talk about things in terms of whether they're unsafe or safe. It's just simply not the appropriate thing to do. What you want to do is you want to stick to the facts. You want to say this is going to increase average annual crashes by 1 crash per year, or this is going to decrease in terms of 2 crashes per year, or we would predict that this particular area would have this many crashes per year. But don't say anything about whether it's high, or whether it's dangerous, or whether it's poor, or whether it's a high accident site. Use benchmarks if you can. If not, stick to the facts and talk about, you know, what you have to detail instead of making a judgment call. Our job is to inform our stakeholders and the public about the analysis. It's not to tell them how to interpret it. Let them interpret it how they want to. If they see that it's an issue, then let them make that call, and don't plant that seed for thought. When you're dealing with best managements for risk best practices for risk management and safety analysis. How do you deal with it? You're going to include the appropriate disclaimers and notices regarding legal protection of data and reports that cite crash data. I'll show you that in just a minute. You're going to edit reports for the unnecessary subjective language. Stick to the facts. I will tell you that when I write my reports, I always give it to the editor and say, I need you to make sure you scrub it for these types of terms. Don't let me accidentally say high crash. Don't let me, provide any sort of safe or unsafe terminology in this document. Please scrub it for me and make sure that those don't exist. And then when you do have to choose an alternative, or when you have to select an alternative and it doesn't compare in terms of safety as potentially the highest performing or the best performing alternative in terms of safety, document the trade-offs and the decisions. This also applies to other things outside of safety studies. This is a really good application and a really good example of what you can also do in design exceptions. So safety data is protected under law, federal law. So what the federal law states is the data and reports that are generated from that data can't be used against ODOT in tort suits. So if we do an analysis and we determine the relative priority in terms of safety for a particular location, and we don't necessarily act upon that immediately, ODOT can be protected because it is not possible to address everything that you study. So the study is the first step, and so ODOT is protected. And then that kind of information in Ohio is really great. We have a great chief legal at ODOT who knows their stuff, and we know how to handle this in court, but it is just something to note that every state is different and every state has different laws. So while ODOT does protect in their own laws against that as well, you should check with your own state to determine if those protections exist. So other considerations, how can you use some of what you learned today for more than just safety studies? Talking about best management for risk, practices for risk management in planning and preliminary engineering. Always evaluate the nominal safety solution for comparison to the solution that you're doing. If somebody's going to say, hey, but it doesn't meet standards, what does that look like? Does it have a worse impact on safety? Go ahead and evaluate that alternative that meets the standards. And this is standard practice anyways when dealing with a design exception. But it should be standard practice when you're dealing with proposed alternatives to provide a basis of comparison. You will justify on considerations other than cost alone. That's a tricky one when you're saying something's the cheapest option, or it's the most expensive option and we can't do it. So it's best to kind of put other variables in as part of the trade-off discussion. You can use the HSM to test the effect on safety of planning and preliminary engineering design considerations. You can also use the HSM to mitigate. So if you have a situation where you have multiple alternatives and you pick alternative 2 in terms of ranking as far as safety, you also should dig into that and say, okay, well maybe I can't make my lane, my shoulder width as wide as I want to. What can I do to mitigate for that? Can I put up some signs? Can I put up some delineation that can bring attention to that, and so that you can attempt to mitigate for something that you have to do because of another constraint, and then you work towards trying to find ways to mitigate and get ahead of any potential crashes that could occur. And then making sure you fully document your engineering work, any engineering judgment and trade-offs that you have. What about in design and project management? The biggest one is document and you need to document all of your design decisions, particularly when they deviate from standard policy and procedure. Big ones, where there is a design decision and there's no design report or record of why the design was implemented. A design with an apparent error for which there's no explanation. Oftentimes we make decisions and it is documented, but then those things disappear. That can be a real issue. And so this is just, something to keep in mind why we are documenting what we're doing at the safety study stage, but we should also be documenting everything that we do throughout project development. Another area that we want to talk about a little bit is that a failure to follow or implement a documented procedure or established policy in completing the design can also be an area of issue and potential liability for ODOT. And that does kind of go with what we're talking about today. You know, we're talking about situations where we're going to be able to appreciate the impact on safety. And, you know, if we can make a decision that, you know, that is a difference or that differs from a design standard, we need to make sure that we're documenting that and why. Because that's an established policy, and the fact that it's an established policy, there is an expectation that the department will follow that unless there is a documented reason why. And the HSM does help when it comes to documenting, you know, the impacts on safety. If we can say, hey, you know, somebody got in a crash here, and they're going to come and come to ODOT because they created a design that, you know, they can prove that, you know, there's a reason why. They could have made a shoulder width larger, or they could have done another attribute, and because they didn't follow standards, there's an implied negative impact to safety. Well, maybe there's other reasons why those decisions were made, and maybe when a safety analysis was done and compared the different alternatives on consideration, there were no differences, or this one was the best choice. Without that documentation of those decisions later on, it's very difficult for ODOT to be able to defend itself against those types of things. You know, and court can find ODOT liable, and that they failed their mandatory duty as professional engineers if they don't have that documentation and can't support it. So those of you who sign design exceptions, you know, some people say, well, you know, the record retention policy is 5 years or 7 years, or, you know, whatever it is. Frankly, any design exception I've ever signed or any document I have that has my signature on it, I'm keeping it forever. Because I want to make sure that not only do I know what I have and I've done, I also want to have that protection in place, and that should be the same for anybody. So best practices for risk management and design and project management. So let's talk a little bit about this. Again, continuing back to that policy or procedure aside here, and it's a little complex, but you know, there's this whole thing about mandatory versus discretionary. So mandatory functions are clearly defined tasks or responsibilities entailing little personal judgment. Highway maintenance activities such as snow plowing can also be following an established procedure. Discretionary functions are involving decisions requiring judgments by professionals. So how to place the highway and establishing the design features, those types of things. So Ohio law holds that discretionary actions are largely immune from lawsuits. But what does this mean? There are things, a little background. So language in OMUTCD and ODOT manuals using shall imposes that mandatory duty. So while we're protected from the things that require our judgment, anything that is established as far as a standard or a policy or procedure, and in particular uses the word shall, is something that we have to do. So if we are going to deviate from anything, we better have good documentation. Now, language was using should or may means that discretion can be exercised, so then you can use discretion. And again, but just because you can use discretion, you need to document the discretion that you're using. So any discretionary decisions or actions should be consistent across the state, involve good judgment, and be well documented. That is how ODOT protects themselves, and that is how we help protect ODOT against risks and liability. So what does it all mean? Establishment of policies and making judgments and decisions are discretionary and are largely immune from lawsuits. Implementation of policies, however, in a fair and even manner in a reasonable time frame becomes a mandatory duty. So once a policy is established, the Court of Claims could hold ODOT liable if it's not implemented properly. And we often influence policy implementation in what we do, don't we? Based on what we're talking about today in our safety studies, we're making decisions and evaluating alternatives and concepts based on their impact on safety, which can influence the way policies are implemented. And so that is why it's even more important for us to document what we're doing and making sure we have accurate documentation. So some best practices for risk management and design and project management. You know, there's some areas of concern where this comes into play, selection of one alternative over another, determining design features of an alternative, the appropriate use of design standards and criteria, dealing with design errors and omissions, and design exceptions or deviations. These are all areas, of concern. Obviously design errors and omissions is a big deal, and while it is in our control, it's out of our control to some extent, but there's also a way that we can use the tools that we have to help evaluate the impact of those as well. So areas of concern in design, construction, and maintenance, just to give a little bit more context to that failure to apply a policy or procedure in a fair and even manner. Where do these kinds of things apply? Or grade crossings, shoulder edge drop off, guardrail, proper installation and timely repair. All of those are ministerial, or the mandatory duties. And so those are carrying out of set policies. So anything that could influence that is something that we also need to be aware of. So what are the best practices to deal with this? How do we get ahead of this? One, we establish reasonable design criteria and adhere to them. Well, some might say, well, we have those. We have the design standards. But the reality is sometimes we have to set standards that are specific to a project. That doesn't mean reinventing the entire L&D manual. That means that we look at some individual design aspects and we determine what's appropriate for that project. The key is once you do that and you determine what's appropriate for that project, that you adhere to that and document the process. First, you document why you might have something that differs from the L&D manual or another manual. And then once you do, you follow that. That's very, very critical. Also, when necessary, you employ design exceptions and you evaluate them properly. You use highway safety manual I really want to have in terms of safety. You use it to mitigate for potential adverse effects. That's the holistic approach to using this. How can we help in what we do? Using the HSM now in the safety study process to inform a decision and documenting that, and then carrying that through the PDP, the project development process, and documenting everything along the way. That's very, very important. It is very important, and I think I mentioned this on our first session, very important that we consider safety and the decisions that are made, even at the planning level, all the way through to construction. When things are changed, it is not sufficient in construction for us to say, hey, if it's a pretty major design change or it changes a major design element, we needed to maybe take a step back and say, what is the impact on safety? And why were there decisions made earlier on in design to develop what was proposed compared to what you might do in construction in the field kind of change? So that was just a little bit of a deep dive into the thought process behind what you can do with some of the information that we provided you today. At the beginning, I talked a little bit about the freeway studies and the freeway analysis areas, the flags that you should, that might pop up when you're doing the analysis. And then we just talked a little bit about once you have all of the analysis done, what can you do to set up, one, your study, and two, the rest of the process as the project goes forward so that it can be most successful in terms of safety. So tomorrow we do have module 4, which will be Alex, and he will wrap things up by talking about any additional studies you might need in order to complete your safety study, identifying and evaluating the appropriate countermeasures. Now that you have the analysis and you know what your potential for safety improvement is, how do you identify the countermeasures and move those and evaluate them and get them to maybe a project step or stage or ready to move on to the next stage, and then developing the plan and finalizing the report. I will pause and ask if anyone has any questions or if there were any questions entered into the chat pod.
There are no questions in the questions pod.
Well, I don't know if that's good or bad, but I'll accept it. So that's fantastic. All right. Well, hopefully you had a good, and it was an enjoyable experience today, and you enjoyed the discussion. We look forward to seeing everybody or talking to everybody tomorrow at the same time. That is all that I have, Paula.
All right, thank you so much, and we will continue tomorrow at 10:30 a.m.
Thank you very much, everyone.